So what's your price?
More than you can afford.
I don't know, maybe I'll win the lottery and give you like a couple mil.
Okay, that would be cool, but not holding my breath there.
Bring a whole briefcase.
And then you wouldn't even have to go to school.
Here's 50.
Okay, so I have the quadratic y equals x squared minus 6x plus 7. In the instructions, it says to identify whether this opens up or down, whether it has a minimum or a maximum, what that minimum or maximum is, the coordinates of the vertex, and to identify the axis of symmetry. And then we would like to write this in vertex form and of course graph it, because why not? So lots of things happening here. What is the easiest of those to identify first? Say that again. If it's opening up or down, and then that will actually tell me if I have a minimum or a maximum. So 2 birds, 1 stone. Sam, how do you know if it opens up or down? Correct. So since it is a positive 1 in front of my x squared, is this parabola opening up or down? Up like a cup.
Wait. So if it's in positive, it opens up and negative down.
Correct. Yep. Since it opens up, does it have a minimum or a maximum? Minimum, because cups have a bottom but not a top.
So I was right about the up or down when I said that yesterday. Oh, I love that. Are you sad? I'm down like a frown.
Oh my goodness. Okay. So I identified whether it opens up or down, and I identified the minimum or the maximum. Now I'd like to find where the minimum occurs and at what y value. How do I do that? Different question. If I have a parabola that opens up like a cup, and that's my minimum, what else do I call that point on a parabola? The vertex. So I can actually find the vertex, and that will help me identify my minimum point. How do I find the vertex of a parabola with the equation like that? Okay, we can put it in vertex form, or we could do what? Oh, I really hope you have this written down.
You have to find
Before that.
axis of symmetry.
How do I find the axis of symmetry?
Opposite of b over 2a.
X equals negative b over 2a. This will help me find the axis of symmetry, which coincidentally is the x coordinate of my vertex and is the x coordinate where the minimum occurs. So when I do this, I pull the a and the b from my equation. My a value is 1, my b value is negative 6. So the negative of negative 6 makes it a positive 6 over 2 times 1, which is just 2. And then what's 6 divided by 2?
A is x squared and b is.
A is the number in front of x squared. So since there's nothing there, we say it's a 1. Sorry, what's 6 divided by 2? 3. So my minimum is occurring at x equals 3. Now I need to find the y value, which is going to be finishing out my vertex. How do I find the y value of x is 3? You plug it back in and solve for y. Everybody do that on your own right now. Plugging the 3 back in for x and solving. Yes, ma'am.
Do penguins have tails?
Yeah, I think they do.
Do they have like little bodies?
Yeah. Why?
It's really is.
Yeah.
At least she finished her.
That's true. Okay. What did we come up with? Negative 2. Okay. So my vertex is at 3, negative 2. And that also means that negative 2 is the minimum value on my graph. Questions or concerns on that one? So the last things I have to do are I have to graph this and I have to change it into vertex form. I know we're super psyched for those. Okay, so I'm gonna graph it first and then we'll do the vertex form thing. So when I'm graphing it, what points do I need and how many do I need? 5. How do you know I need 5? Or why do I need 5?
You said that on your note.
Right, but why do I need 5?
Because sometimes
So, because you have vertex, and then you're gonna have the 2 on one side, and then you're gonna have the ones that match on the axis of symmetry.
Look at that, on the opposite side of the axis of symmetry, right? So I have my axis of symmetry, which is my vertex. Then I'll have 2 points on the left that will have 2 identical points on the right. 5 points lets me graph it. Do I just make the points up or do I find them somehow?
Find them.
How do I find them? What x values will I plug in for this equation to find my other 4 points? Because I already have one of them.
0, 1, 2. Oh, we already have 3.
I already have 3.
0, 1, 2.
So we just do 2 and 1. We don't need 3 on one side. But yes, I would do 2 and I would do 1. 1 step away and 2 steps away. So I would like you guys to do an XY chart, plugging in 2 and then plugging in 1 and then graphing it on your own, and then we'll come together and I'll have somebody do it for us.
I do it.
Do they get-
The only thing with
You take 2, plug it in. What's 2 squared? What's 6 times 2?
Oh,
You just plug it in and solve it.
oh.
We are all doing this right now, right? It's really good practice.
I've already done it all. I know. I did something from.
Oh, I have to do. I don't have that.
It's my first time. So good. I was drawing. Should I be
Yeah.
Oh, that's cute.
Yeah, and the drama is that.
I would like.
Oh,
I would be.
hey, who wants to graph this? You're up, right now. Pen's up there.
I don't have that.
Gotcha. Okay.
I just have
So the head of an elephant on a penguin. Oh, the head of a penguin on an elephant.
Well, don't make me move.
Oh, my graph's gonna look great.
Oh, trust me. Okay.
At this point, all of you should be comparing your work with cadences as she puts it up.
Yeah, okay.
You're doing whatever you want. Yeah.
Shane.
Yes.
I have to listen to that in class too.
Wow, that looks great.
It's a beautiful parabola.
You guys like it? It's pretty.
That is a fair point.
Show of hands. Who has a parabola that matches cadences?
Just needs a little bit of curve.
Yeah, she just needs some TLC, but it's fine. It's fine. I have a question for you. Did anybody have any major issues plugging that in? And if so, what were they? Nobody at all. So all of you are gonna get 100% on that question if I had to put one on the final
I
thing.
swear.
No.
Probably not, but
Because I'm gonna forget about it. I had it.
good thing I give partial credit. Really good thing I give partial credit.
Yeah, we're not getting.
Okay. Don't say that.
We're gonna get at it.
We're not done. Yeah. Nope. Ladies and gents, are we finished with this problem? No, what am I missing? The most fun part of this whole thing.
Oh, yeah.
So vertex form.
Wait, we gotta do axes.
No,
My bag.
that was this.
What?
That's our axis. Is right here.
What?
Yeah, the 3. Yeah. X equals 3. It's also the x coordinate of our vertex. Okay, so there are 2 ways that we could do whatever it's called, vertex form. There's a way where we just take the vertex and then we measure some stuff on the graph and do it that way. That one's easier, so I'm gonna do the harder one as a refresher for you guys. Because, well, completing the square is gonna be really, really important here. So, to get this into vertex form, I'm gonna go ahead and rewrite it. I'm going to need to move my constant 7 over so it's with my y. So when I subtract it over, I get y minus 7 equals x squared minus 6x. Vertex form has a factored x, which means I have to create a perfect square trinomial on that side. It's going to be a beautiful quadratic that's going to factor into the same thing twice. So I have x squared minus 6x. What do I do with that 6x to create this perfect quadratic? Divide it by 2 and square it. So what's half of negative 6? Negative 3. What's negative 3 squared? Positive 9. So I'm going to add a 9 here. And to keep it in balance, I'm going to add a 9 there.
Wait.
So I took half of negative 6.
Yeah, that's so.
And we got negative 3. And then I take negative 3 and I square it. Because that's how we build the factors.
Okay, so I got get rid of anything.
Nope. Once we do that, it allows me to identify the same number that multiplies by itself to get 9 and adds by itself to get negative 6. What's it going to be?
6 and negative 6x.
So what times itself equals 9 and what plus itself equals negative 6? Negative 3. Coincidentally, it's always half of whatever this term is. So then this factors into x minus 3, x minus 3. And then equals y plus 2, because negative 7 plus 9 is 2. And then I can rewrite the x plus 3 times x plus 3 as, x minus 3, as x minus 3 squared equals y plus 2. Yes, Sam?
Is it okay that I wrote it y plus 2?
Yeah, other sides don't matter. I just moved it because it was getting cramped over here. That does not matter at all.
I got that without doing that.
Yes, there are multiple ways of doing it. How did you do it, Cadence?
But because I know it's y minus the opposite of y, the opposite of x.
Okay, so this is the other way of doing it that is somewhat easier, but I like to show both ways as a refresher. My vertex form is y minus k equals a times x minus h squared, where k and h are the coordinates of my vertex. 3 is h, negative 2 is k. So when I plug negative 2 in here, I get y minus a negative 2, which becomes y plus 2. My a value is the coefficient on the front of my x squared term. So it's just, I don't know. And then x minus 3 squared because h is 3. So it comes out to the same thing either way.
Where do you get the A for 1?
It's the number in front of my x squared. A is the number in front of our x squared if we're given it in expanded form. An A.
Equals 2 minus, or can you put it y equals x minus 3?
I prefer, since vertex form has the number with the k, with the y, I mean, I prefer they're on the same side, but I wouldn't count off if you just moved it over. That's okay too.
That's so much easier than doing
I do it both ways because maybe there's a point where I say, hey, complete the square to do this, so you should know how.
that. We have to do that on the final.
Good to find out. Okay, any questions on that? Yes, Bolt.
Okay, so vertex form is the y equals x minus 3 squared minus 2, and then the standard form is the one that's right equals 2.
Correct.
And the 2 can be like on the right side of the x minus 3.
Oh.
Yeah. I prefer if it's over here, but it doesn't matter. Say that again.
How many questions on finals?
I'll say 2, maybe 2 that relate to it. They're not all like this though.
I'm definitely not.
Just relate to it maybe in some way, shape, or form.
This one was gonna be hard.
It's just
Everything I
practice.
know how to do, I guarantee is not gonna be on there.
Right, I
Back,
swear,
come on.
everything.
Everything.
Come on.
It's every test we
Can we
take.
just
Everything I
do
know how to do
synthetic
is not on there.
On the final?
Just all that.
That's just synthetic division, the entire final.
I think we should
That would be kind of fun, I'm not gonna lie.
I'm
Why
right
can't we just
I
do
love
synthetic
synthetic
division? That'd be like-
Yeah, let's just do long division.
I would just get yelled at until like.
Okay, so now we're gonna go the opposite direction. This is number 10. So this one asks us to identify our vertex, our axis of symmetry, and then put it in standard form and then graph it. I probably am not going to graph it with you guys. You guys can do that on your own. It's not that bad. I'm more interested in the vertex, axis of symmetry in standard form. So looking at it the way it is right now, can I identify my vertex?
Wait, no, it's 2.
Yes or no?
Yes. So,
I'm getting an underwhelming response right now.
I'm pretty sure. Yeah, you can.
Say it again, Cadence. I can't. What do I need to do to be able to do it? Okay, vertex form is y minus k equals a times x minus h squared. So what I need to do is I need to add the 4 over with the y. That way when I take the opposite signs of those numbers, it works. So I add that over and I have y plus 4 equals 2 times x minus 1 squared. Now I can go ahead and pull out those values and fill in my vertex. So our vertex, remember, are the coordinates HK, which means I'm taking the number grouped with my x, pulling it out and taking its opposite sign, and that's my x coordinate, so that's a positive 1. Then I'm taking the number that's grouped with y, pulling it out and taking the opposite sign, and that's my y coordinate. So my vertex is 1, negative 4. Without any work, do I also know my axis of symmetry? Yes, what is it? 1. It's the x coordinate of my vertex. And then the last thing I have to do is put this in standard form. How am I going to do that? Okay, so I'm going to have to rewrite x minus 1 squared as x minus 1 times x minus 1. So I have y equals 2 times x minus 1, and then the minus 4. I need to FOIL out the x minus 1, x minus 1. When I do, I get x squared minus x plus 1, and then minus 4. We combine like terms. Then what do I do? Distribute the 2. Y equals 2x squared minus 4x plus 2 minus 4. And then finish combining like terms. And I get y equals 2x squared minus 4x minus 2 as my standard form. Questions, concerns, or issues with that? Okay. I'm not going to do number 11 because it's kind of just along the same lines, except it's given to you in vertex form and not vertex, intercept form instead of standard or vertex form. Still works out the same way. Do we want to look at 12 and 13?
Yeah.
Yeah, okay. So number 12 says to write the quadratic function whose graph has a vertex at 2, 3, and goes through the point 0, -1. What information have I been given about my quadratic? The vertex. So what form do you think I'm going to be plugging things into? Vertex form. Whatever it gives me is the form I start with. So vertex form is y minus k equals a times x minus h squared. 2 is my h, 3 is my k. So when I plug it in, I get y minus 3 equals a times x minus 2 squared. So I plugged in the vertex. What am I still missing for this to be complete? The a value. So how do you think I'm going to find that a value? I'm going to plug in 0 for x and -1 for y, and I'm going to solve. So the other point is going to help us determine what that a is. So when I do this, I get -1 minus 3 equals a times 0 minus 2. Of course, I'm going to go ahead and simplify this out as much as possible. -1 and -3 is -4 equals a times, what's 0 minus 2? -2. What's -2 squared? 4. So I have -4 equals a times 4. So to get a by itself, I need to do what? Divide the 4 over, and I get -1 equals a. So to complete this problem, I go back up to the vertex form I already identified, and I replace the a with a -1.
Wait,
Yes, ma'am.
there's a way. Do you have to like do that way? Or can you just do it from your head?
What do you mean?
Okay.
Do what from your head?
Well, when I did it, I just looked at the points and then I thought about absolute function transformations or whatever that was. I was like, and then I graphed and I was like, you go this way and then this way, and since it goes down, it's a negative.
Okay, so I knew it had to be a negative. You just got lucky when it was a -1. It could have been a -2
Well,
or a
yeah, well,
-3 or a
that's
-4.
Well, yeah, because you fill in for the points that is already there, and you have to figure out what times what number equals.
So kind of the same thing we already did. Kind of.
Sort of.
Sort of. Yeah. Yeah, you can kind of do it that way. That's okay. That's just, yeah, you cut through an alley or two on the way. That's all.
Will I get any credit taken off?
No. I am not one of those people that says you have to do it my way or no way. I want you to find the way that's comfortable for you, and that's the way I want you to use. If it works, it works. You get the credit. Even if I don't necessarily agree with it or I think it could have been done better, I don't care. I'm not the one who has to do the problem. You are. So whatever way works for you is the way I want you to do it. I will adapt my grading to that, always. Okay? It's not a ride or die kind of situation here. It's not my way or the highway. It's whatever way works for you. Except for cheating. I don't do that. Just saying. Okay. So number 13 is extremely similar to this one, so I don't necessarily think we need to work through it. Just know that instead of setting it up in vertex form, we set it up in intercept form. I'll show you how to set it up, but we won't solve it. So on 13, since it told me I had x-intercepts, my intercept form is y equals a times x minus r1, x minus r2, where r1 and r2 are the x-intercepts that I'm given. So on this specific problem, it said my x-intercepts were -3 and +1. So when I plugged it in, I would get y equals a times x minus a -3, and then x minus 1. It gave me another point on this graph as well. So I would do just what I did before. I would plug in whatever the x value is for that point, plug in the y value, and then solve for a. Just like the previous problem, it says that another point is 220.
Yeah,
So
but
I-
how do you know which the 3 and 1 goes to?
It doesn't matter which one. Yeah, it does not matter. I'm not saying they will, but I'm not saying they won't.
Is Alex there?
I'm sure he is. Questions, concerns, or issues with this one? Do you want me to go through this one? Okay, that's fine. So it told me the other point on this graph is 220, where 2 is my x and 20 is my y. So I plug those in, and I get 20 equals a times 2 plus 3 times 2 minus 1. I go ahead and I solve those individual parentheses first. So I have 20 equals a times, what's 2 times 3?
6.
Or 2 plus 3?
5.
5. And then what's 2 minus 1? So then 5 times 1 just becomes 5. And then 5 times a is 5a. To get a by itself, I need to do what? Divide by the 5. And I get 4 equals a. So then I'd go back up to this, and I'd replace my a with the 4. That's all you do. And then, of course, like I said, to graph it, but it didn't, so you're good. Questions, concerns, or issues with that one? Go ahead. What's your question? Oh, you're just showing off your
My
drawing.
tattoo sleeve, my awesome tattoo sleeve. Yeah.
I love it.
Yeah, I do.
Okay, so 14 are simplifying. Do we want to go through all of these? See? Genuine question. Do we want to go through all of 14? Or are you okay if I just do like C and maybe D?
Yeah, D is the
So
one.
you do like C and like A. C and D.
That's true. We'll do C and then I'll do A and then I'll do C. How's that sound? Okay. So
I don't know how to do it.
we pass no judgment anywhere in here. That's fine. 14A. I have negative 2 plus 14I minus 6 minus 2I. Somebody talk me through this process. Cool, go ahead.
You look at the -2,
Okay.
and then you look at this, and then you look at the subtraction symbol, and then you look at the 6, and then you go -2 minus 6. So -2 minus 6 is obviously -8.
Okay, to make it a little bit easier, why don't we go ahead and distribute this negative to both terms? Then we don't have to try and like find our way around that. So negative 1 times 6 is -6. Negative times a negative is a positive 2i.
Okay.
I do agree with what Bolt said though. I have to combine my real terms, which are -2 and -6 to get -8. Then what do I do, Bolt?
And then you add the 14i plus the 2i because there's an I there.
So
And
that
then
becomes
you go,
16i squared, right?
No, it's a common way.
No.
Again, 14i and 2i becomes 16i squared, correct?
No.
No.
It's addition.
What is the only way to get an i squared?
Multiply?
Thank you.
You silly goose.
I know. How could I? Follow-up question. If I were to get an i squared, do I leave it in the final answer?
No.
No, because I squared equals what? There you go.
So you change it.
If I had like an I squared, so if I had like 5i squared, that I squared would become a -1, and then it'd become a -5 answer. Yeah, go for it. And then we're gonna do C, which is rationalizing the denominator. Yes.
Oh, that's okay. I thought your eye was the top of your eye was negative.
Oh, no, sorry. Just the dot.
No, that's a different singer.
Okay, 14D, or C, sorry, wrong one. 32.
We're almost done.
Okay, as I'm looking at this problem,
Wait,
Alright.
did you get rid of the eye?
yeah, the I would disappear because it's I squared gets completely replaced. I would like to simplify this problem. When I simplify it, it means there's no longer an I left in my denominator. So anytime I have addition or subtraction involving I's in my denominator, to get rid of it, I multiply by its what? Or its, what's the word for that? Conjugate.
That's a word.
Yes. So what is the conjugate of 1 minus 3i? 1 plus 3i. So I'm going to multiply 1 plus 3i into both the numerator and the denominator of this fraction. When I multiply, we multiply straight across. Make sure we're not like crossing fraction bars anywhere. And then if I have a binomial or 2 terms times a 2 terms, I have to FOIL. Make sure you're paying attention to those rules as well. So we multiply straight across. I'm going to do the numerator first. What's 4i times 1?
4i.
What's 4i times 3i?
12i squared.
12i squared. Then I go to my denominator. I need to FOIL this. So what's 1 times 1? 1 times 3i.
Negative 9 squared.
Not there yet. 1 times
Oh.
3i. I do
I
first
thought you
all
were
of them.
done.
No, you're okay. Is 3i. 1 times negative 3i is negative 3i. And then negative 3i times 3i is negative 9i squared. I'm going to pause here. Make sure we all understand what just happened.
It's not confusing at all.
Not at all. From here, I can simplify. I have several things that cancel in the denominator. And then I can replace my I squares with negative 1s. What's wrong, Brandon?
I lost.
Okay, where are we lost at?
No, I was trying to figure out how you got negative 3i, but I figured it out.
Okay. So the 3 i's cancel, which is what I intended to happen. My I squares, I know I can replace with negative 1. So then this becomes 4i plus 12 times a negative 1 over 1 minus 9 times a negative 1. Of course, this simplifies. 12 times a negative 1 becomes a negative 12. We always put real numbers in front of my imaginary. So I also reorder that at the same time to put the negative 12 first. And then in my denominator, negative 9 and a negative 1 becomes a positive 9. And 1 plus 9 becomes 10. No, we have to simplify, but then we're done.
We can simplify and cancel.
Yeah, so what whole number comes out of 12, 4, and 10?
It's not done.
2.
2. So when I take a 2 out, I'm left with negative 6 plus 2i over 5. You could always go one step farther as well and separate this into 2 terms, putting each of them over 5. And if you wanted to do that, it would not be wrong, but it would become negative 6 over 5 plus 2 over 5i. Some of you like to do that. That is not a required step. I'm okay with this. Questions, concerns, or issues on that one? D is just like it, except you'll have to FOIL the numerator and the denominator on that one. So then we get to the lovely number 15.
Oh my God, there's so many. 1, 2, 3, 4, 5. 6, 7,
I will
8,
tell you there are not an overwhelming number of factoring problems on the final exam, but there are some.
So is it like
Out of the 15, I would not do that. That's outrageous.
Well, there could be like number 1, have the whole alphabet.
Wait, how many
Yeah,
questions
are
are
we
on?
gonna have 11?
How many questions? 15. Exactly.
So how many
They all
A, B,
always
C,
have like
D?
an A or G. I can promise you that no question has more than 4 parts to it. Like I didn't do the whole alphabet on any of them. I didn't go to J or H or anything like that.
Teacher gives 2.
Because you
I
went
most
to-
definitely did not.
Because you went to K on this
Well, yeah, it's a review. It's different.
one. 11.
Okay, the one that has the biggest number of parts goes to E.
Wait.
So 5 parts. Okay. So 415A. It asks me to factor this one completely. As I'm looking at it, to make it easier, sometimes some of these are going to fit our Special cases, sometimes they're not. So is this a difference of squares? I should probably write it first. This is not a difference of squares because it's not two terms. It's also not a difference of cubes or a sum of cubes because it's not two terms. And it's also not a perfect square trinomial that's going to factor into the same thing twice because 2 is not a perfect square and neither is 12, which means this one is just good old-fashioned factoring. When I'm good old-fashioned factoring, because I know it's been a hot minute since we've done it, I always look for a common factor first. Is there anything I can take out of all three of those terms?
No.
No. After I check for a common factor, and I still have a number in front of my x squared, what do I need to do? Rainbow. We need to rainbow. That means I'm multiplying that first coefficient into my third term and rewriting the quadratic. So when I do, I get x squared plus 5x minus 24. And then I factor it just like normal. I'm looking for two numbers that multiply together to get negative 24 and add to get a positive 5. I knew that was mine. Oh, no, I wasn't sure if it was mine or mine.
Don't even talk about that. Okay, thank God.
Yeah. Jalen's gonna finish that out.
Oh.
Turn it now.
Oh, what? Yeah. But it's fine.
Okay.
You look like you was. Okay. What are you doing, Jalen?
8 and negative 3.
Okay. We are all paying attention, right?
And then,
So keep talking. You're gonna get on the stairs. And then as you come down the stairs, do the doorway to your left.
Come on, I need to learn this stuff.
It's over by like this.
just gonna be able to teach you.
I'm aware. Okay. So yeah, Colin, walk him down, please.
Then do I
Okay, we are listening to what Jalen has to say.
I haven't said
Okay, let's say it now.
it. So I did 8 and negative 3, those multiplied to negative 24 and add to 5.
Okay.
And then I did this. And then I think I divided by 2 now.
Yes, you have to divide out the number that we rainbowed. This is the number one forgotten step in this process. So we need to divide each of those by 2. If it does not reduce and we have a fraction, what do we do with that denominator?
Put it next to the X.
Kick it over with the variable x. So that x minus 3 halves becomes 2x minus 3.
Well, that was
Okay.
I'm definitely.
And then write the other factor with it too. No worries at all.
I guarantee I'm not gonna remember.
That's okay. It's not wrong if you don't, it just looks nicer. Okay. So as I'm looking at this problem, where are we finding issues? Not issues with Jalen's work, issues like with doing it in general.
Wait, we have to.
Oh yeah, you have to end it with.
Oh.
We're not done.
Well, I didn't want to solve it. I just wanted to factor it.
Yeah.
So factoring would stop here. If I wanted to solve it, then I'd have to set them equal and do it that way.
What's the double?
Any questions on rainbowing or factoring that way?
So it's not called Skittles?
You can call it Skittles if you want to. Okay, so any that we did not get to, I will create a video for and I will post it after school.
The whole second and last page.
Pretty much. Have an absolutely wonderful, as stress-free as possible day.
Oh, yeah.
Yeah, I can join the video. I got it. Again.